I just knew. Oh, it does that. Okay. Oh my gosh. There's the doctor's office again. I'm sorry. Okay. What I want y'all to do is read the first part of the Explore framework. I'll be right back. I'm sorry. I have to take this. I am so sorry. Now you're going to have all the answers to the questions I was going to ask you. Yeah, oh, I'm so sorry. I have to have surgery next Friday, and like I had to pay so that they wouldn't drop me from the books for the procedure. So I was like, yeah, okay. What am I looking for? Did y'all read? Cool. Okay. So why do we explore? Like, don't read from it, but tell me, why do we explore? What are some of the reasons?
See ways that different variables interact.
Ways variables interact. Why do we care about the ways variables interact?
We want to get to know the data we're working with.
Very much so. Why do we want to know the data we're working with?
Because then we can make inferences about patterns in the data.
Yeah. And what do we learn if we know, if we can, Barbara, what were you gonna say?
Oh, I was just going to say, looking for missing values and filling in missing values.
Definitely. That is a huge value of exploration. When we can see the patterns, what are we learning?
It's helping us to answer our questions that we asked at the beginning in the project planning phase.
So it can help us identify our drivers.
Exactly. Our drivers of our outcome, which is our target variable. That's awesome. Why else do we explore?
Some correlations may not be very obvious until you've flipped the data around on its side and looked at it from another angle.
Totally. I'm going to generalize that a bit more and say some relationships. Is that okay with you? Some relationships are not obvious until you've run it through a magic machine and looked at it again. That was my way of saying flipped it on its head and did, like, yeah. What else?
I think sometimes it's easier just to visualize what's going on because it's really hard just to interpret a bunch of numbers on a screen.
Very much so. See what's happening in the data. Numbers are hard to detect patterns in visually. Yeah. So we want to find drivers. Essentially, we want to understand if there are things we need to change in our data. So like errors, missing values, how we want to handle those. We want to understand how our independent variables relate to our dependent variable. We also want to understand how our independent variables relate to each other. And that's not something we're going to address that we have addressed in a large way in classification, but we will when we get to regression. But we want our dependent variable to be related to our independent variables. We don't necessarily want our independent variables to be related to each other. We want each variable to provide unique and awesome information about our dependent variable. I know that sounds very vague right now, but we'll get there. We're not going to worry about that for this project, okay? That's called interdependence. There's a lot of different names for that. But yeah, everything you've talked about, data integrity issues, handle missing values, how our variables relate. Understanding the data, finding the patterns. Do you remember what I told you about the stop sign, right? That the stop sign, a stop sign is a stop sign. It's there, but if no one can see it, it's not very useful, right? So if your algorithm can't see the patterns, it's not very useful. And so we need to help the algorithm see the patterns. When we can help the algorithm see the patterns, then it can see the patterns deeper than we could see it, right? Let me say it this way. If I can see certain variables, how they interact with the target, like I see this variable has an interaction with the target, I see this one does, and I see this one does, and I've created a new one that has a great relationship. So I've kind of trimmed the shrubs around the stop sign, right? And then the algorithm helps me see how this plus this plus this plus this interacts with the target. I couldn't see that one on my own because my tools are limited in the number of dimensions, right? That I can visualize. But the algorithm can tell me more. So if I can trim away the bushes, the algorithm is going to be very helpful for me.
Yeah.
Did y'all hear that? He didn't. Maddie walked down the hall and goes, yay, algorithms. Okay, so that was funny. Any questions on that? Does that make sense? Yeah, okay, cool. So, oops. See, yeah. Okay, so that's why we explore. Our goals in exploration generally are going to be to remove redundant variables. That's the interdependence I was talking about. Remove vars that add no value or information. Create stronger features. We'll talk a little bit about that. That comes with practice. That comes with doing it more and more, starting to understand how the data works, how patterns exist, things like that. It's just but I'll go through a couple of examples. Be able to explain the feature target relationships. Those are the primary goals. Okay. How do we do that? We do it through statistical testing. We do it through visualization of using charts and using tables. Okay. We do it through asking questions too. So this is where it gets good. This all sounds well and good, just feels a little vague. It's like, okay, so how do I do it? It sounds like a lot. What do I do to get there? Well, so I have sort of a little formula for you that I think will be good. So, and I mentioned this briefly earlier this week, but if we think about it in terms of univariate, bivariate, what does univariate mean?
One variable.
Yeah, thanks, Lori. Bivariate. Multivariate. Okay, technically multivariate. Bivariate is a form of multivariate. Yes, okay. But I split it up and am intending multivariate to be more than two. Okay. So this will help give us this framework. First, we explore univariate, right? We plot all of our variables and we say, okay, let's first do this. Before we do any of this, let's split our variables into whether they are categorical or I'm going to call them quantitative or numeric or continuous. You get the point. They're ordered, they're numeric, and there are too many to be classified as classes. How about that? Okay. So we split our variables into those two. Our target will fall into one of them, right? In this case, our target is categorical. In the case of telco churn, in the case of Titanic, our target is categorical, right? Okay, so if we think of univariate as trying to understand the distribution, so here, let me actually do this. I think I like these colors. Categorical, quantitative, and then our target falls in here. Okay, so in univariate, for the categorical variables, we do a bar plot to understand the ratios, different ratios, and a frequency table that gives us basic counts of each class and proportions. So count and percentage. Okay. For the quantitative, we'd like to see a descriptive statistics. So like the dot describe that you can run on numeric variables. So descriptive stats, histogram to see the distribution of each individual variable, and maybe a box plot just to see the distribution in a different form. Okay. And after we see all of that, we always document not that color. I'm trying to think like there we go. We always document takeaways, findings, lack of findings, whatever. Okay. Then we get to bivariate. So these, you can get an idea of what these look like, right? Like we're talking bar plot of class 1, class 2, and count. And then we're also talking about like a frequency table. And this is count and percent, right? Something like that. Okay. And then with this, we're talking about like your variable, and then your min, max, 50th percentile, etc. Right? And then we have a histogram that is always perfectly normal, right? Because that's the way it works in the real world, right? And then we have a box plot, right? Okay, so that's what we're talking about there. I forgot to record.
No, it's recording.
Thank you, whoever did that. Thank you. Okay, so then bivariate. What are we talking about here? So when we're talking about bivariate, we're talking about two variables, right? When we think about the goal of exploration, we think about the goal of identifying the features that are drivers of the target. So when we're talking about bivariate, we're talking about plotting each feature with the target, comparing each feature to the target. Okay, that's one goal. The other we're not going to get to right now, but the other is comparing each feature to all other features. Okay, I'm not going to do that right now, but when we talk about comparing each feature to the target, again, we have our quant and we have our categorical. Okay, so what does this look like? Well, with categorical variables, if you remember, our target is a categorical variable. Our target's a binary categorical variable. It's the same in telco churn too. I'm thinking of Titanic, and it's the same in telco churn. So what do these plots look like? We create a plot, a simple bar plot, but where the y-axis is, let's say churned. The x-axis is your category, and it's a bar of the average rate of churn for each class in that category. Because this is between 0 and 1, right? So you kind of got your average churn for each category, and then you've got your overall average churn rate. So you can view it that way. We can view it as a crosstab, right? Where it's like churn by fiber. Right, you have a crosstab. And you can also run a statistical test. What kind of test?
Chi-square.
Good job, Steve. Chi-square test. And look at the outcome of that. So we've got 1, 2, 3 useful things right here, right? Because if this is significant, then there is likely a relationship there between fiber and churn. Okay, so with quantitative variables, with some common things we can do, some useful things is we can look at descriptive statistics again by our target, right? So if we have our target as churn or not churn, and then our variable, our continuous variable as monthly charges. How about that? So monthly charges. And we can compare the 50th percentile of monthly charges for churn and not churn, the 75th, the mean, all that, right? We can also plot, let's say, you can plot like this, where churn is now a categorical variable, and our y-axis is our quantitative variable, like monthly charges, right? And we could do like a swarm plot, where we have like something like that, right? Maybe those who, it's actually not the case, but maybe those who churn pay more. Okay, what kind of test could we run?
T-test?
Yes. Steve, you get 2 good smelly stickers or something, I don't know. We could run a t-test if it met the assumptions. We don't know if it does or not. So what I'm going to do to be safe is I'm going to run the non-parametric version of the t-test so that I don't even have to test the assumptions. And if it gets close, then I can worry about it. And if I want to like test the assumptions and stuff, but that means that like I can quickly see the big drivers without having to test the assumptions. So I'm going to run a Mann-Whitney, which is the non-parametric version of the t-test. Basically, what we want to do is we want to compare means. So we got those, right? Okay, so we've got univariate. This is really messy. We've got bivariate, and I didn't put the last part of this. What am I missing on this section? Takeaways. And then finally, we've got multivariate. Now, multivariate, we can divide into 2 parts. We can divide it into the kind of standardized process part, which is going to just produce a bunch of like general graphs, charts, and then we could have the creative part. And that's where we ask the questions. Ask and answer questions. So all of these steps up to this point can be standardized, all depending on whether you have a categorical variable or a quantitative variable. And you can just we can quickly produce all of these charts up through this point. And then, you observe them and you You document your takeaways, you look at the outcomes, document your takeaways, you go through all of that, and then you start asking the questions after you know more. And when you get to asking the questions, you use the functions that you've used in here. Okay, so let me show you this. So what's the standardized process of the multivariate? What's a common way to represent a binary variable in a chart when you want to represent 3 variables?
Dummies?
In a chart. You have 3 dimensions you want to plot. You have your X, you have your Y. Where are you putting the 3rd dimension?
Could use a hue.
Hue, yeah. Hue is usually the best one. The best next dimension to add. Hue. So now what we have is we can plot our categorical by our quant, and then we can add a hue for target. Okay, so we could do a swarm plot, for example, where categorical is there, quantitative is there, and then we have different hues for the different targets. So like maybe we have purple, and what's a very different color than purple? And yellow, something like that, right? So now we're getting to dive in a little deeper. We can see the interaction of 2 variables with our target. Okay. We can visualize, we can create a grid of all of them. We can visualize when we have quant versus quant, right? What can we see? And then we add color for target again. What was that one? And we can use, in that case, we can use a pair plot where we have a grid of plots of every quant variable plotted against every quant variable. Right? And the ones in the middle are histograms because it's plotting against itself. Right? And then maybe these are dot plots. Oh, but we got to add color. You know, you get the point. Right? Now we're seeing even more information. So what? Okay, well, again, we document our takeaways, wrong color. Wrong color still. Takeaways, right? And then finally, we get to the really fun part. But the cool thing is that we get to the fun part faster. We get to this part. And that's where we use the knowledge that we've learned from all of this, and we ask really smart questions about our data. And generally, these questions look like this. They're about taking a subset of your data. Let's say we're talking about telco, okay? At this point, we have explored every variable by itself. We have explored every variable with the target. We have explored every variable with another variable with the target. We have done all of that with the entire set of our training data. So we know pretty much everything about that at this point, right? What we don't know are what's happening in the little subsets of those. So for example, of our fiber customers, do those who churn pay more than those who don't? What's the only difference in that versus this? It's a hard, I'm giving you a lot right now. The only difference?
Find fiber customers as opposed to all customers.
Yes, exactly. That's the only difference. So how do you do this? You take a subset and then run it through this thing. So then you're like, okay, I just want train where train.fiber equals 1. And that's my sample. And then I'm going to run it through that to see if charges make a difference and churn. So this part is about asking questions, taking subsets, and basically doing kind of the same things you've got going here already. Another example would be of our phone customers. Does having fiber make a difference on churn? So what's my subset in that case?
Phone customers.
Yeah, all customers who have phones. So I filter down to that. And then what kind of test am I going to run? And what kind of plots? Categorical, quantitative, mix? It was of my phone customers, do those who have fiber churn more or less?
It would be categorical because they either have fiber or they don't have fiber.
Exactly. So let's look at this for real. Let me stop that share. Oops. Is the size okay? Okay. Okay. So the three major functions that we're going to use, that those three sections I showed you in the drawing, we're going to use explore univariate, takes in train, data frame, a list of categorical variables and a list of quantitative variables. Explore bivariate and explore multivariate. And those functions will produce everything I just showed you. Okay. So let's look at this real quick. The goal right now is not to look at the code in detail, but to look at the structure of it and what it returns, okay? So I'm going to, we're acquiring our data, our Titanite data. Doing some prep steps. Okay. We're splitting the data. Looking at the shape. And then we're going to explore. So univariate stats. Explore univariate. So currently, my categorical variables are these. And my quantitative variables are these. I put sibling, spouse, and parent children in categorical. They only go to 5 or 6. The swarm plots or scatter plots are going to get really, really hard to read anything into if I use it as a quantitative. So I put it as category. Could do it either way. So when I run this function, because I've put this in my explore.py file, and I run this function, and you'll see that it's going to start out for each categorical variable, it's going to return the bar plot and the frequency table. Okay. Survived. We can see 60% quickly see 60% did not survive. The class. We can see that 48% were in second class. Sibling spouse. We can see here that a takeaway for me quickly here is that I want to blend everything. I want to bend these so that everything that is 2 or more is just in 2. Because these numbers get really low. So that's one takeaway I get from that real quickly. I look at parent children. Same thing. I'm going to put everything that's 2 or more into 2. Embarked. Majority of people came from Southampton. The port, let's see, alone. More people traveled not alone, which would make sense since not alone means there's more people with you, which would increase the numbers of more people not traveling alone. I could continue, but not. So basically that's what I would kind of expect. Female. Almost 63% were not female. Age. Okay, we can kind of see, we can see the distribution of age. We can see, I probably could get away with assuming normality on age, kind of, but kind of, yeah, I don't know. Not gonna worry about that. But yeah, I can see that the youngest is half a year, oldest is 74. Okay, let's see, fair. I was gonna make a really bad joke. It's not appropriate, Maggie. Sorry, I just had to talk myself down from it. Okay, so, oh, $15. Yep, so you can see fair, definitely. We would not want to assume normal distribution with fair. So walk through that. You document takeaways, those things that I just said, some other things that I've mentioned here. Let's see. What did I say? Sibling, spouse, and parent children bin so that they fall into one of 3, 0, 1, or 2, where 2 represents 2 or more. There we go. Some takeaways, 60% did not survive. So this will be my baseline prediction because it's the highest. So my baseline prediction will be not survived, and it will be, and my baseline that I want to beat is 60% accuracy. Cool. survived can be treated as either a categorical or number. So this tells me that I can use survived on a y-axis as a like proportion, and I can use it on an x-axis as like 0 or 1. It also tells me I can use it as my groupings for comparing means. I can compare those who survived, the mean of X of those who survived versus those who didn't survive. Things like that. Okay. I don't want to get into too much detail. I want to go through the overview and I got kind of caught. Sorry. Okay, so we did the univariate and then we do the bivariate. So explore bivariate. The only difference in the arguments here is we add the target variable. Oops. So explore bivariate and train, target, and categorical variables, categorical and quantitative variables. I just wanted to confirm the list. Currently, so when I was doing the univariate, I added survived to the categorical list, right? But since survived is a different argument here, I want to take it out of that list. Oops, I should probably run these so that I get. So yeah, so I used survived as a categorical variable, but now it needs to be a separate argument because remember, we're going to plot each variable against target, right? And so I just removed it from that list. So when we run this, what we end up is for each variable, for the categorical variables, it's going to run a chi-square test against survived or didn't survive. It's going to return a crosstab of the frequencies and the expected values of the frequencies and a bar plot. So there's the average of survived. And then we can see that first class was much more likely to survive. Third class was much less likely to survive. And we can confirm that with this p-value right here. Does that make sense? So for each categorical variable, it does this. It's going through and doing that. Sibling spouses, the same. We can see, I mean, it's right on the border of significance. I think we'll probably see more significance when we group these together. But when we look at the chart, we can see there's too much variability here to say anything. Not really sure. But it definitely looks like, I think when we add these all together into, pretty sure that we'll see that those with a sibling or spouse are probably more likely to survive than those not. Parent children, much more significant there. And if we look at this, we can see definitely those traveling with parents or children more likely to survive. Embarked. There's a significance here from embarked and survival. Let's see what it looks like. Embarking from Cherbourg was a good thing. Traveling alone. This is kind of like removing a lot of the noise of parent, children, sibling, spouse. This was a constructed feature that didn't originally exist. And so those traveling alone were less likely to survive than those traveling with others. And we can see that was significant there. Female, very significant. And there you can see this graph supports that. This chart supports that. Right? So now we get to the quantitative variables. So what's it going to do with the quantitative? It's going to create a boxin/swarm plot. So a boxin plot is like a box plot, but with the deciles instead of quartiles. So you get to see a little more detail. Layer the swarm plot on it and you can see, you see a little more, you can understand it a little better. So it's going to plot that and it's going to give you the descriptive statistics. So what is the average age of those who did not survive versus those who did? What's the standard deviation, min, max, etc. So you can look at this, and then it will run the Mann-Whitney test. And as we would expect, there is not much difference in an age of 30 and an age of 29. The p-value supports that. And in terms of fair, what would you guess with fair? I would guess that fair. Oh, sorry. Go ahead. Who was going to talk?
I was thinking like first class individuals had higher fares, right? So they're going to survive.
Exactly. Yeah, we already saw that first class was more likely to survive. We assume that first class has higher fares, so there's probably some significance here. And we see that the fare of those who survived is much higher than those who did not survive. And that is supported in this p-value right here. I had not finished documenting all my takeaways there, but yeah.
So do the departures have really low p-values? Like where they departed from? Because I can't really see that being like a cause to their death or their survival rates. It's more of like a coincidence.
So that is a great question. And I'm going to add this right here. This is a great example. This is a question that you could ask at the end. This is a great question because what's likely is that departures are correlated with something else. Like maybe passengers who departed from Cherbourg were more likely to be first class, or maybe they were more likely to be families.
Yeah, okay.
And so that's what you would test that. You would kind of look at those who departed and see if, look if there's a relationship between class and departures. And that would be a chi-square test. Yeah, great question. And so you would document these questions down here, and these you would come back to once you get to the end of the standardized part, and you pull those questions out and answer them. And so we would, so here, this is one of the steps that I'm going to want to do is add this to prep, but temporarily I'm going to add it to train so that we can use it in exploration, which is been parent, children, been sibling, spouse. And then I wanted to add is adult because I was seeing that there were kids that were like, it looked like kids were more likely to survive because of, well, you've all seen it. So I do that. Now I'm going to recreate my list of categorical variables. And so now we get to the last step, the multivariate stats. Okay, we start generic and we will just explore all the multivariate, the different combinations. Where a target is survived, we'll pass the data frame, the target, the cat vars, and the quant vars. It's working. So you'll see that it is plotting each categorical variable by each numeric variable. So each row is a numeric or quantitative variable. And then the color represents survival. It does it with a swarm plot, and then we do it with a violin plot. Okay. And then we have a pair plot of the quantitative variables. So age by fare. And when it does age by age, it creates a histogram or a density plot. The shape of the histogram. Okay. And then finally, it creates that melts the data frame into a long data frame with the quantitative variables that y'all had in an exercise, and plots age and fare. So you can see them side by side. This is most useful when our data has been scaled. So when all of our data is on the same units, this will be very useful. We should probably move this to the regression module after we've been scaling. But I just wanted to point that out. So what you'll do is you look through this. What do you notice? Tell me something you'll notice. Let's do it together.
Most of the children of a young age look like they survived, right?
Does look like that. Very much so, even in third class when no one else survived. I'll even put regardless of class, of passenger class. What else?
It appears that a lot of adult men died.
Yeah, sucks to be an adult man, especially if you're traveling alone.
Each of those tick marks were 10 years, right?
Yes.
On the age? Okay. So probably like every 18 plus, yeah.
Yeah. It looks like about that. What else? Okay, I'll give you one. Females, regardless of age, it appears, to survive. Looks to me like those traveling with one or more parents or children were likely to survive. Survive.
Embarked from sea looks like it's got a pretty good survival rate.
From sea. Cool. So what's interesting here that we can get that we couldn't get before is especially that first one, is that children survive, because if we look at children regardless of class, regardless well, actually, this is interesting. Looks like it's possible. I'm putting a lot of assumptions on here, but I'm curious if the family was too big, were they less likely to survive? But anyway,
would you say Queenstown on Embarked is not really statistically significant? I mean, there's just not a whole lot of people.
Yeah, it's hard to say anything with it. Yeah.
With Liam's question, looking at the multivariate, is there not a way that it could have done fair as your y-axis, survived or not as your x, and then use a hue for Embarked Town? Is there a reason why that wasn't, why it wouldn't pull that?
The challenge with that is that you can't standardize that as easily. So by keeping survived as your color, you're always looking at the colors mean the same thing across the entire chart.
Gotcha.
Yeah.
You have to like do a specific chart just for that, just to pull it.
Yeah, exactly. And that's good to do, but yeah, for the generic one. So if we look at parent, children, and fair, embarked and fair, we can see that there's probably something to that, right? It looks like, well, no, I don't know. I can't tell you. But look, there's some really high fares up here. They were definitely more likely to survive. Let's also look at were there more children. What's that?
Would that be those 3 people who paid those high fares be from the first class?
Most likely, yes.
Yeah.
Yeah. Because we did most likely, I can't remember what the fare was, but most likely all of these above. Well, we can look right here. There's class and fare. So we can see there were no second or third class above like $90 or something. So yeah, everything you're talking about, these are things that, like, whether it's a question or a statement, you document it down here. Like that. And you can confirm that later. Okay. It's easier to document it and then not need it than to not document it and need it and don't remember what it was. Okay. So then there's the violin plots, and here's this. So you go through each one, you spend time looking at all of them, asking these questions that we were just doing. Thinking about the data. In doing that, you are preparing yourself to talk to others about the data too. Okay. So we do all that through those 3 functions. And now you get to spend your time observing it as opposed to trying to write the code for it. And then you can get creative. So some questions, sample questions I asked just as demos are males traveling alone less likely to survive than males traveling with others? So what's my subset here?
Males?
Males. Yeah. So I create the male subset. And then I'm talking about traveling alone versus traveling with others. And that's a categorical, right? So I'm comparing that categorical to our target, which is categorical, right? So I'm going to use a sub function that's also in here that you'll see. So this function helps build the explore bivariate. So explore bivariate categorical is the one I'm going to use. My data frame is now male subset. My target is survived, and my categorical is alone. I run it and I quickly get a p-value, frequency table, and a bar plot. And the answer is kind of. So not at the alpha of 0.05, but there is some relationship there. Remember, I'm using a much stricter test also. So it's not super strong, but my guess is that because kids are more likely to survive and adults are more likely to travel alone than kids, then males traveling alone are probably more likely to be adults and less likely to survive. So that's kind of my thinking in that. Of the females traveling alone, is there a difference in age of those who survived and those who did not? So my subset is
Female?
females. It's a little more specific though.
Their age? Or traveling alone?
Females traveling alone.
Exactly. So your subset doesn't just have to be a very simple one. It could be like of the fiber customers with phones, or like whatever, of the fiber customers on a month-to-month contract. So in this case, I'm wondering about age, if there's a difference in age and survival. So in that case, I'm looking at the quantitative and I want to compare means. So I'm going to explore bivariate quant. There's my data frame. There's my target. There's my quant var bar. And what that returns to me is this plot, the Boxen plot with the swarm, the descriptive statistics. And my question is there a difference in age? When I first look at the age here, 29 versus 32, that doesn't appear to be much of a difference. When I look at the p-value here, that confirms that. Oh, thanks, Madeline. I was wondering that. So, any questions on that? So I would put, there is not a significant difference in age of females traveling alone versus those who did not. This is all, some of these answers may give me a direct action plan of create this variable. Some of them just lead to a better general understanding of what's going on. Okay. Of the females traveling alone, again, same subset, was passenger class the difference in those who survived versus those who didn't? And so in this case, it's passenger class versus survival. So it's categorical. Again, the same subset, survived versus P class. And I run it and I see yes. But it's not just first class. It's not that first class is more likely, it's that third class is less likely. And so that's an interesting finding. So if you wanted to, you could even create features that were like the most significant findings you found. You could create a feature that was female and third class, adult male traveling alone. Like you could do a lot of work for the algorithm. Nothing wrong with that. Of passengers in third class who survived. So what's my subset? Passengers in third class. So now I'm diving into third class. And my question is very vague. It's more of an exploratory question as opposed to a very specific question. So I don't know. I'm curious about the interaction of all the variables of this subset. So in this case, I am just going to explore bivariate for that subset. So I'm going to do the third class subset. My target is survived and my cat vars and my quant vars. And obviously, we're talking about only third class, so this one doesn't mean anything. When we look at sibling spouse, there is definitely no relationship there. So passengers in third class, whether you travel with siblings or spouse, that doesn't mean anything with this data. One key thing to look at is what is your sample size. You want to, when you're starting to take subsets, you want to make sure you have a representative, a large enough sample that makes sense to analyze, because you can start to get really small. So, parent children. So it's interesting, right? The sibling spouse didn't make a difference, but the parent children did. So third class, those who were traveling with one parent or child were more likely. Two was also, but not as much. Embarked. So anyway, it's getting kind of long, but I don't. Oh, embarked. Okay, third class embarked. Look, Cherbourg. Embarking from Cherbourg in third class, more likely to survive. My hunch is those have children. Families in Cherbourg. Because these are only third class. The count isn't high. Count's still pretty low, but still. Cool. Females. Adult. Yes, child in third class is more likely to survive than an adult in third class. And that p-value is pretty low. There we go. And then finally, age. And we would expect a significant difference in age in third class of survival. Yes. And there we go. And fair. Now, remember, we're comparing only third class. So this is interesting. So the fares should be probably about the same, right? And there's no difference in fare of those who survived or those who didn't. Those who paid higher fare, they're like, screw this. I'm just kidding. Okay, so document your takeaways. And at the end, so there was one more, third class passengers traveling alone. Were there any who survived? That was an interesting one to me. So it was I was just like curious. So it was a subset, another subset, and it was just all bivariate, like another general question. And it was interesting that only 19 out of 103, 18% survived, which is much lower than the overall percent of 40%. And females were much more likely to survive than males. Let me go to, there we go. So these are third class passengers traveling alone. Okay, there is that. Where do you get this? So, so I have this file that I gave you access to. This has all of the functions, including a train, test, validate. But here's the explore univariate function. Okay, here's the explore bivariate and the explore multivariate. And within each, you'll see that there's the explore univariate categorical and explore univariate quant. Okay, so those are the ones, or well, not actually, the bivariate was the one. So explore bivariate, and then there's the explore bivariate categorical and the explore bivariate quant. So if you're asking a specific question, like we talked about, that you know is going to need a chi-square test or a t-test, then you would want to do one of these functions. And if you're asking a general question, you could do the explore bivariate. Or you could just always do the explore bivariate and answer your question through that. Does that make sense? So when I said explore in 5 functions, the 5 functions I meant were this function.
I don't think we are seeing your screen.
Oh.
All we see is the explore framework.
Oh, you're not. No wonder y'all were lost. Thank you for telling me. Can you see it now? Okay, so here is the explorer.py. And when I said explore in 5 functions, 5 functions I'm talking about is this function, this function, 2, 3, 4, and 5. And the steps, univariate, document takeaways, bivariate, document takeaways, multivariate, document takeaways, ask questions, answer questions. Thoughts, questions, concerns, hopes, dreams, fears. Just kidding.
Just gratitude from me.
So in a final notebook, I guess you'd want to see, wherever we found correlations, right, with whatever our business problem is something you wouldn't want to see like every single chart that we make in this explore section. You'd want to see the
Yeah. So that's where, and that's
relevant ones.
That's where you can practice, and you can just create a single chart of that specific thing and plot it in the best way possible that can, or in a way that best represents it or whatever. Totally.
So this help us with our models, right? After like the features that we want to focus on. And
this will really help you with getting started and explore and not getting lost. It will get you able to work through Explore really quickly. And then the only charts you really need to focus on making are the ones that you're going to put in your report. Which is good because it will still give you practice in the making the chart. At the same time, it's really easy to get so lost in Explore where it's almost like it's hard to get through it, and you can't make as much progress on any of it because, yeah. And so I'm hoping this will help you feel more comfortable and to be able to move a little more fluidly through the data and the creative process.
So, I mean, obviously your walkthrough was very extensive because you had the time to get or to explore a lot. We shouldn't expect ours to have as many explorations. Are you expecting just as many?
No, so here's the thing, I'm giving you these functions. So you will have the same explorations because all you'll need to do is create your list of
categorical and
quantitative, and then run these functions. So my time was all spent. I did spend a lot of time on this, not exploring, but creating the functions.
I was literally like, so I just finished my acquire and prepare, and I was just about to like build this. So I'm very thankful.
Feel free to any improvements you make, you can send them to me. So you're going to you'll probably run into a few tweaks, like where if you have like too many categorical variables, it's going to create too many columns on the multivariate one. I want to work on that one, but if you spend time and fix it, please let me know. So. But there's ways to get through it. If you have too many categorical variables, you could just break it into 2 pieces or something.
I think that's the least I can do.
Oh, thank you. Anything else? This hopefully will save you tons of time. I should have not showed it to you yet and let you do Explore on this project, actually, now that I think about it.
Okay. Yeah, no take backs.
No take backs. I already pushed it. You already have it.